We are going to go ahead for this problem, and we are going to find the inverse of g. The inverse of g. And then we're going to graph both the original function and its inverse on the same window on our graphing calculator. So in order to find the inverse of this function, I'll come back and I'm going to put the answer in this box. But what I'm going to do is I'm going to treat this like a y, and this is an x. So when we find the inverse, we're going to switch the y and x. So I have x equals the cube root of 8 minus 2y all over 6. There is another unique way to write this, and I'd like us to write this down. I'm not sure if you had this in the video or not. This little nth root here, called a cube root, can also be written as a fraction in the exponent position. It's 1 over whatever number that is, always. Whatever number that little nth root is can always be written as a rational exponent. And that will help us when we are going about trying to isolate the y at this point. So if our goal is to get y by itself, I need to get rid of all the outside stuff. So first I would get rid of on the outside of the parentheses anything that's being added or subtracted. There's nothing on the outside of the parentheses being added or subtracted. Next I'm going to get rid of anything that's being multiplied or divided. Currently I'm dividing by 6. The opposite operation is multiplying by 6. So to both the left and to the right, we're going to multiply by 6. So we're doing PEMDAS backwards. There was no adding or subtracting outside the parentheses. We took care of the multiplying or dividing. Next is going to be our exponents. So I want to remove this exponent. To remove this exponent, I'm going to raise it to the reciprocal. So I'm going to take both the left and the right side, and whatever I apply to one side, I have to also apply to the other side. I'm going to multiply it by the reciprocal of the exponent. And I want you to know why. I don't want you just to memorize that procedural. The reason why is our goal is to get rid of this exponent. When we multiply by the reciprocal, we end up with 1 times 3 is 3, 3 times 1 is 3, and that reduces down to 1. Having 1 as our exponent does not do anything. I'm able just to leave it as is inside the parentheses. Now off to the left hand side, I have to take this exponent of 3 and I have to apply it to both the 6 and to the x. So within your groups, no calculators allowed. What is 6 times 6 times 6? No calculators allowed. What's 6 times 6 times 6? 216. The big mistake here is that students maybe apply to the 6, but then they don't apply to the x. Both the 6 and the x need to be cubed. So 6 cubed is 216. X cubed is obviously x cubed. Okay, now we're going to take care of our last thing. We've done adding, subtracting, multiplying, dividing. We've taken care of the exponents, and now we're on to the parentheses. So when I'm trying to isolate this x, my next move will be to subtract 8. When I subtract 8 to the opposite side, they can't be combined because one has an x cubed in fact, and the other does not. And my last step here will be opposite of multiplying will be to divide. And this is a key fact from freshman year. Remember, this has to be shared with the left side and also with the right side. So I will do this the slower way. I'm going to take 216. I'm going to divide it by -2. -8 divided by -2. And now y is by itself. What is 216 divided by 2? 108, bring down the negative sign. And a -8 divided by a -2 is a +4. Now, how do we identify this as being different than the original function? We identify this as being the inverse by writing this -1. So I'm going to take this, I'm going to go back up to the original equation, and now I'm going to write this in, -108x cubed plus 4. Obviously, I write pretty big, and my handwriting is pretty sloppy. As you're doing your work, if you don't have enough room, take out a piece of paper, and we will staple it onto the problem. Okay, so this is what I have. Okay, we are now taking out our calculators together. Are you ready? On your paper, I'd like you to make a box that looks like this. We're going to start with this very first problem. Okay, please do second plus 712. Second plus 712. I'll adjust this so you guys can see my calculator. Go up to y equals. I'm going to start with the very first function. I'm going to put parentheses around the numerator and parentheses around the denominator to separate the two. So parentheses. Now, how do I find that cube root? If you hit math on the left-hand side, you can go down to the fourth option, and this is the cube root option. Inside, I'm typing in 8 subtract 2x, and then I want to go outside of the parentheses using the arrow, and I want to end that quantity. So that's your numerator. We just ended that quantity. That's my numerator. I'm going to divide that by my denominator. Okay, when you're done, I want you to go to Windows, and this direction specifically said have the window from -15 to +15. And then please hit graph. It's really hard to see that. Would you guys agree? Yes? Really hard to see that? I want to go in a little bit closer here. I'm going to take this y value just so I can see it a little better. I'm going to go -5 to +5 in the y's. And I may even adjust that with Zoom Fit in just a second, but I want to narrow this down to closer to the x-axis so I can see. Okay, I got it. So that's what I have. So we have this shape that looks like this. We have this shape that looks like this, right? Okay, so I'm going to come up here, and I'm going to draw this shape. So I can see, by the way, look at this, right about 4. Do you see where do you see at 4 where it dives down and then it makes that shape again? So right about 4, 1, 2, 3, 4. It's coming in like this, it dives down, it goes like this. Okay, next up, our next one. So we're going to leave this on. It's very nice compared to the older calculators that you guys have, or the one I have at home that doesn't have the color feature. So go back up to y equals, do not erase that. Let's go down to the second option that happens to be in red. The second option that happens to be in red. Now I'm going to type this in next. So I'm typing in -108 x to the third plus 4. When you're done, I want you to hit graph. Okay, I'm going to do something similar. I'm going to take this, and I can see something's happening, but it's really hard to see what's happening. I want to take this, and I want to compress this. So I'm going to go up to Windows, and I'm going to go from the x's. Let's just try first doing like -8 to +8, and let's see if we have a little better view of that. Okay, a little better view. So I'm going to come up here, and it looks like this. At about 4 up, do you see how at 4 places up, it veers to the left, and then it keeps going up? So 1, 2, 3, 4. It's going up, and at 4 up, it veers up, and it goes like this. Okay, maybe you remember this from freshman year algebra. Go back to your third option, and let's go back and make it black. I want you to type in just a singular x. Now hit graph. If we took the red function, the function we see in red, and we took the function we see in blue, and we were somehow able to print this off in a color printer, and I said fold along that line y equals x, do you see how the red and blue would lie directly on top of one another? That just proved to us graphically that these two functions are in fact direct inverses of one another. If they do not look like this, where they fold directly on top of each other, they are not inverses of one another. So within this unit, we're going to learn later how we can determine if two functions are inverses using algebra. But at this point, we are using a graphing calculator to identify this. So here's what I have. His sheet didn't go directly through this, but please do yours directly through this. The line y equals x will always cut through the first and the third quadrant, evenly through the first and the third quadrant.